back to lab, AP Chem students, and today we are going to be doing the buffer and lemonade lab. Just a reminder, the beginning intro to the lab is talking about the capabilities for a buffer to both react with an acidic environment and a basic environment, which helps keep that buffer's pH pretty consistent as long as we don't, go over the capabilities of the buffer, the amounts. So please read through that carefully. And then to get into the lab, we are going to be doing two sets of data here. We're going to be titrating a buffer solution, which is already done for us. That is in our Country Time lemonade. Country Time lemonade has citric acid and then also sodium citrate, which adds its conjugate base into the solution. So there's a mixture of the two, and I've already measured out 40 milliliters of the lemonade. That will add to a beaker, and then we're gonna just titrate it with 0.1 molar NaOH. And we're going to be collecting pH data as I add the titrant NaOH. And then we'll run the experiment a second time, but this time we are going to be using a non-buffered solution of just citric acid. Same concentration as the Country Time lemonade, 0.1, and we'll still be titrating it with NaOH. And then you guys will take those two data sets and graph them into a titration curve, and you'll be able to compare and see the difference between a buffered solution and a non-buffered solution, how the pH changes as the titrant is added. All right, so for the lemonade trial, I have it all set up. I poured the 40 milliliters of the lemonade into some distilled water, just to make sure we had enough volume that the stir bar at the bottom wasn't hitting our pH probe that's in there. And then I have the burette set up with the 0.1 molar NaOH right above. In fact, I tried to line this up right at 0.00 milliliters to start with. And the idea is I'll add 2 milliliter increments all the way down until our pH gets to that point where we get through the equivalence point and we get into the basic region. Okay, so here's our initial pH with 0 NaOH added. All right, and we'll add the first 2 milliliters. All right, here's the addition I made. Line the stir bar, mix it up. And here's our pH. Here's our next addition. And our pH. Here's our next addition. Next addition. And the pH. Next addition. And the resulting pH. Next addition. And our resulting pH. Next addition. Next addition. Getting close to the burette clamp. And the pH. See if I can get right in there. Next addition. pH as a result. Addition. There's our pH. Try to get it right in there. Our next addition. Our pH. There's our next addition. More level there. There we go. There's our pH. Here's our next addition. I went a little over 2 milliliters on that one. Sorry guys. I'll let you adjust it in your notebook there. And then our pH right there. Try to get that one right there at 26.00. And our pH. Fluctuating a little bit more. We'll call it there. There's the next addition. There's our pH. Starting to jump and waver. It's jumping. Let's take it there. There's our next addition. pH. Now it's not fluctuating as much. Wonder what that means. Here we are with our next addition. Sorry, I'm shaking hands. And our pH. We'll take 2 more data sets here. There's our second to last addition where we're at. Here's where our pH is at. And we'll take 1 more. All right, here's our last measurement. And our last pH measurement for that. All right, now that you have all the data for the buffered solution, pH volume, go ahead and turn that volume pH into a graph, titration graph. Volume will be on your x-axis, pH will be on your y. And then we'll go ahead and collect the data for the non-buffered, just the pure citric acid. All right, time for citric acid. So I poured the 40 milliliters of the citric acid into some distilled water, again, to make the volume large enough that the stir bar on the bottom wasn't hitting into our pH sensor. Refilled the burette with 0.1 molar NaOH just to get it back up to a level of 0.00 for initial. And our pH for that starting volume, not adding any NaOH into that buffered solution, or buffered, listen to me, non-buffered solution, is 3.12 or 3.11, your choice. All right, there's the first addition to the non-buffered citric acid solution. And the pH is here. There's where we are after the second addition. Our pH. It's right there. There's the volume on the burette. Here's the pH. Here's our next addition. Here's our pH. It's kind of steady here. Here's our next addition. And our pH. Next addition. And the resulting pH. There's our next addition. Oh my, there's our pH. next edition is right there. Here's our pH. Maybe add 2 more after this. Meniscus is kind of between the twins here. I think you guys can read that okay. And our pH, as a result, is right there. Much more steady now. This will be our last reading. Got it right to the 20. And the pH, because it's staying pretty steady now, we'll end it with there. All right. There you go. Citric acid titrated out. All right, finally, you have all the data for the non-buffered solution titration. What I'd like you to do is graph this data on the same graph you created for this data. So you get like a side-by-side comparison. You can use different colors for your titration graphs line to compare the two. And then you can go through and answer or do the calculations for table 2 and see what you can do with these questions. All right? Good luck. See you back in class.